Okay, section 3.2. So our focus will be on properties of determinant today. Okay, properties of determinant. Here is theorem number 3 from this chapter. Let A be a square matrix. Remember, if the matrix is not a square, then we cannot find the determinant. Okay, for the determinant to exist, it must be a square matrix. Let A be a square matrix. Then if a multiple of one row of A is added to another row to produce a matrix B, then determinant of B equals determinant of A. What it means is we are allowed to do the row operation in determinant as well. Okay, and the determinant will be the same. So the row operation that we did earlier, that is allowed. What kind of row operation? If multiple of one row of A is added to another row, that is the operation which is allowed. Now, if you interchange the row, if two rows of A are interchanged, then in that case, we must change the sign. Okay, if one row of A is multiplied by K to produce B, then determinant of B equals K times determinant of A. So then we have two more properties. Let us talk about all of those 5 properties of determinant, okay, with examples. Now, first one is if each element of any row or column of a determinant is multiplied by a constant K, the new determinant is K times the original. What does that mean is, let's say, okay, property number 1, I'll write P1, okay? What it means is, suppose you have, let's say 2A, 2B, C, D. You have this matrix. I'm talking about determinant, so let me write another sign. Okay, determinant. 2A and C, 2B and D. Then this can be written as 2A, B, C, D. That's what it means. Or if you have, let's say, for example, 4A, B, C, D, then we can write this as 4A, 4B, C, and D. Or we can write 4A, we can write A, B, 4C, 4D. We can write this way, or we can write 4A, 4C, B, and D. So what it means is if you have to multiply this, then you can multiply with either one row or one column. Doesn't matter which one, but you can multiply with only one row or column. And this is very different from matrix. So if I have a matrix, let's say 4 times A, B, C, D, if I want to multiply this with matrix, then it will be 4A, 4B, 4C, 4D. In case of matrix, we multiply every element of matrix with that factor. But in case of determinant, we just multiply with one row or one column. Okay, doesn't matter which row or which column, just keep that in mind. That's property number 1. Let's look at property number 2. If every element in a row or column is 0, the value of the determinant is 0. So property number 2, what it means is, suppose you have a determinant, let's say A, B, 0, 0, then the determinant will be 0. Because notice that if you cross multiply, then you'll get 0, right? Or you can also say that if you have column, let's say A, C, and 0, 0, then this also will be 0. If there is 0, all zeros in one row or one column, then the whole determinant will be 0. That's what it means. If you notice, all the zeros in either any row or any column, the determinant will be 0. That's property number 2. Property number 3. If 2 rows or 2 columns of a determinant are interchanged, the new determinant is the negative of the original one. What it means is, property number 3 is, suppose we have A, B, C, D. And if you want to interchange that, which means let's say C, D, and A, B, if you want to interchange that, you must write minus. Okay, the interchanging row or column, you have to write, you have to change the sign. Or suppose you have A, C, A, B, C, D, for example, and if you want to interchange the column, for example, let's say B, D, A, C, you can do that, but don't forget to write the negative sign. It will change the sign. Okay, that is called, that's property number 3. Interchanging row or column will have negative effect here. You must write negative there. Property number 4. If the corresponding elements are equal in row or column, the value of the determinant is 0. So corresponding element, so let's say P4, suppose you have A, B, and you have A and B. Then in this case, it will be 0 because the first row and second row have the same element. Okay, if they have the same element in any 2 row or any 2 column, then the determinant will be 0. In the same way, let's say I have A, B, let's say AB and AB, for example. So in this case, this first column and second column have the same element. So if any 2 column have the same element in it, then the determinant will be 0. That is property number 4. Now the property number 5. If a multiple of any row or column of a determinant is added to any row or column, the value of the determinant is not changed. So what it means is, let's say property number 5. Let's say I have A, B, C, D. These are the elements in the determinant. Okay. Now what I want to do is, let's say I want to do, this will be equal to, I want to do some row operation here. I want to do in R2, for example, or in R1, doesn't matter. I want to do R2 plus, let's say, KR1, for example. Okay, K is a constant. K is constant. Then in that case, I did nothing in the first row, so I just copy that as it is. In the second row, I decided to do R2 plus KR1. So R2 means C plus KR1 means KA. And here D plus KB. So the determinant of this and this must be equal. They are equal. And also, if you want to do, let's say, instead of that, you can multiply with column as well. Okay, let's say you want to do this C in C2, or let's say in C1, for example. In C1, you want to do, let's say, C1 plus K C2, for example. Then what do you get? Okay, from this one here, if you do that, in C1, you did C1 plus KC2. So that means A plus KC, B plus KD. And then column, we're talking about column. So column, in column 1, A plus KC.
KB.
KB, sorry, yeah, KB, A plus KB, thank you. And this will be C plus KD. And we did nothing in column 2, so let me just copy as it is. So this one and this one are also equal.
Professor,
Okay, guys, now example 1, I would like you to compute this determinant by using the method that we learned in our last class by expansion. Okay, let's say here, method 2, expanding. Let us expand a third row. If you expand third row, so you'll have, remember third row means this one, A3 1, C3 1. So 3 and 1 is 4. That means it will be positive. And then minus A32, C32, and then plus A33 and C33. So A31 is -1. C31 will be, this is gone, this is gone. So first, third row and first column, ignore that. So you're left with -4, 2, 8 and -9, and minus, the sign is negative, because I didn't write the sign. Basically, the sign should be like this. It should be written like this way, -1 power 3 plus 1. I think by this time you're already familiar that when the sum is odd, then this will be negative. If the sum of this row and column is even number, then that will give us positive value. So this one will be positive, but there is -1. Let me just write -1 and this will be negative A32, which will be 7. And 32 means your third row and second column is gone, so remaining is 1, 2, and -2, 9, -9, and plus A33, which is 0, so I don't have to write that. So if I work it out, I'm going to get -1, and this will be 36 minus 16 minus 7 here, and you'll get -9 plus 4. So how much is that? Is that 15? Okay. All right. -15 or positive 15. Let's see. Okay, guys, so this method you already know, expanding the third row, we got 15. And for this question, that's the answer. But here, what we would like to do is, let us try to use some of the properties that we just discussed, just for fun, okay? So by using some property, method 1, I call it method 1. And let us use some property. So determinant of A, we need to find the determinant of A. So determinant of A can be written as 1, -4, 2, -2, 8, -9, -1, 7, 0. Notice I'm using this 2 vertical line. In earlier, it was a matrix. And if it is a matrix, we must write the word DET, determinant. But if you write this 2 vertical line, you don't have to write that determinant, okay? This is what we need to find. Determinant of A is this. Now, just out of curiosity, let us, try a couple of properties here. Let's say I want to do R2, let's say R2 plus 2R1. Let's use this property 5. Again, you don't have to do this way. I'm just trying to give you, some opportunity here to practice some of the properties that we just learned and see whether it makes sense, whether we get the same answer or not. So that, and if we get the same answer, then you will be convinced that yes, all these properties really works, right? Okay, now let's do this. R1, I did nothing, I just copy as it is. In R2, I did this R2 plus 2R1, that gives me 0. And this also gives me 0. This gives me 2R1 is 5. Is that -5, I believe. And third one, I did nothing, just copy as it is. And let us do, let us do something with R3 just for fun. Let's say R3 plus R1, what happens? And R1, I did nothing, I just copy as it is. And in R3, I did R3 plus R1, that will be 0. This will be 3. This will be 2. Okay. Let's try, another property. Let's say R1 and R2. Let us interchange. What happens? Guys, again, you don't have to do this way. I'm just trying to, play around a little bit here with all those properties. What we'll get here is that, remember, in this case, we must change the sign. If we interchange the row, sign must be changed. So I'm going to change this R1 and R2. Let's say I'll get 0, 0, -5, 1, -4, 2, 0, 3, 2. All right. And now I would like you to expand this and see what happens. Expanding maybe R1. Okay, let us expand R1. So that's going to give me this first one will be 0. And the second one is also 0. And then the third one is, remember, there is negative sign here. Equals negative sign is there. I just copy that. And the last one will remain, this will be, sign will be positive, -5, and I'll get this is gone, this is gone. So you're left with 1, -4, 0, and 3. We'll get that, right? Maybe I'll use this symbol. Now, what I got here is that negative is there and -5 is there. And so if you find the determinant of this, you're going to get 3 times 1 minus 0. So that's going to give me negative times negative will be +5, 5 times 3, which is 15. And that's what we got, right? So we did a lot of, fun thing here. We just applied those rules. We just play around a little bit with the properties, and then we decided to find the determinant, and we still get the same thing. Okay, so what I'm trying to say here is that, all those properties that we just discussed actually make sense, right? That's what I'm trying to say. Even though you know how to expand it and find the determinant, that's great. But sometimes if you remember those property, it makes life so easy. For example, if I give you, let's say 1, 2, 5, 9, then 10, 14, 27, 0, 1, -900, and then 1, 2, 5, 9. For example, if you are given this, then if you expand it, it takes a lot of time. And notice here that this row and this row, they have exactly same element. So by the property, the answer will be 0. You see how much time you saved, right? That's all about properties. Okay, we know this property that if it has the same element in either in one row or one, either in 2 rows or 2 columns, then the determinant will be 0. That is one of the property. And now you get the answer right away. This may be a little bit confusing. So we are talking about determinant, okay, not the matrix. So the matrix property does not apply as it is. For example, in the matrix, when you wanted to change it into echelon form, you can interchange the rows and it doesn't make any difference in the final answer, right? But here, when you interchange the row or column, the sign must be changed. But in the previous lesson that we know, we cannot interchange the column. We can interchange only the row. But in determinant, you can change row, interchange row, you can interchange column as well. But only condition is that if you interchange rows or column, you must change the sign. That's it. All right, now let's look at this example. I leave this example too for you to practice, play around with those properties and solve it. I leave it to you. Now we're going to learn one very important theorem. A very important theorem. Theorem 4. A square matrix A is invertible if and only if determinant of A is not equal to 0. Please keep this in mind. Very important theorem, okay? So this type of questions are given in exam quite often. Okay, let's look at example 3. Is A invertible? Where A is this. We are given the matrix A, and our job is to figure out whether the inverse of this matrix exists or not. It doesn't tell us find the inverse. It just tells us, the question is just telling us whether the inverse exists or not. That's we need to figure out. So what we have learned from theorem 4 is that if the determinant is 0, then inverse doesn't exist. If determinant is not equal to 0, then the inverse exists. So basically, in this example, we are supposed to find the determinant of A. That's all we need to we need to find, okay? So one way is to do this is expanding, just the way we did before, okay? So method 1 is expanding first row, first column, second row, second column, third row, third column, fourth row, fourth column, or you can expand anything. Now this one I leave it to you. Try this by yourself. We have done that in our last class. Now in this case, we just want to use a little bit of this property, okay? Let us play around a little bit. So determinant of A equals, I just want to copy the question as it is, 3, -1, 2, -5, 0, 5, -3, -6, -6, 7, -7, 4, and -5, -8, 0, 9. Now let's do one thing a little bit. Let us use R3 plus 2R1. Again, do you have to this way? Do you have to do this way? No. But I'm just playing around a little bit with the properties, what happens, okay? Sometimes it makes life easy. And there is a reason why I wanted to choose R3, okay? I think you'll notice that later. Sometimes common sense actually helps a lot. If I do that, let me just write down what I get. So R1, I did nothing. I just want to copy as it is. R2, I did nothing. Let me just copy as it is. And R3, in R3, I did R3 plus 2R1. So what do you get? It will be 0, 5, -3, -6, and then R4, I did nothing, -5, -8, 0, 9. Right, we notice that the second row and third row have exactly the same element, same numbers there. Therefore, by using the property number, I think whatever, number 2, 3, using the property that we discussed earlier, it will be 0. And yeah, so I think it saves a lot of time. If you use this expand, method 1, it takes a lot of time, but here we are able to save quite a lot of time using this properties. All right. Now, let us try one thing here. I want you to it's extra example, okay? Let's say consider A equals 1, 1, -4, 2, -2, 8, -9, and -1, 7, 0. I want you to find determinant of A. You can use any method that you like. And I also want you to find determinant of A transpose, which means if you do the A transpose, you're gonna get 1, -4, 2, -2, 8, -9, and -1, 7, 0. I want you to find this as well. And let's see what is the relationship between determinant of A and determinant of A transpose. So now we can say that, you see, determinant of A is 15 and determinant of A transpose is also 15. And this is not a coincidence. This always works, guys. So we notice that determinant of A equals determinant of A transpose. So this is one theorem we just proved experimentally. This is what the theorem 5 tells us, okay? This theorem tells us that if A is a n by n matrix, then determinant of A transpose equals determinant of A. We have just seen that, okay? The proof, mathematical proof is there. It's not required for exam point of view, and those who are interested, just read this and you're okay. We have just proved that experimentally. Now here is theorem 6. Before we go to theorem 6, I would like you to do this. In example 4, we are given two matrices. I want you to calculate the product of A and B, okay? Multiply A and B. It's a matrix multiplication. And let me know. And then once you have the product, so the product will be, I believe this is 25 and okay, this is what I got. And so determinant of AB will be 25 times 13 minus 14 times 20, and that's going to give me, I believe, 45. Okay, so we got the determinant of AB, product of AB, okay? Now, let us find determinant of A. Determinant of A will be 6132. That's going to give me 12, 6 times 2 minus 3 times 1. So this will be 12 minus 3 is 9. And determinant of B is going to be 4, 3, 1, 2, and that's going to give me 8 minus 3, which is 5. So determinant of A times determinant of B equals determinant of A is 9 times 5, which is 45. Notice here that these two values are equal. And this is not a coincidence. That's exactly the theorem, theorem 6 is telling us, okay? So it shows that, hence, what we have proved is that determinant of AB is equal to determinant of A and determinant of B. So this theorem is proved. Any question?